Triple threat for severe weather today, including damaging winds up to 60 miles per hour, large hail, and maybe even an isolated tornado. Good morning, I'm meteorologist Pew. Today is July 20th, 2025, and I forgot to charge my microphone, so please excuse the audio. We have a slight risk over a 2 out of 5 in 3 separate areas, and from the northern plains to the Mississippi and Ohio Valley and the Northeast. And we're going to have a couple major hazards today. The first is that we're going to have winds up to 60 miles per hour in all the risk areas that we're talking about today. 2, we're going to have large hail, specifically in the northern plains. And 3, we're going to have major flooding, possibly in central Illinois. The Weather Prediction Center is issued a moderate risk or a 3 out of 4 in central Illinois because this area has already been seeing rain from yesterday, today, and also again this afternoon and evening. So this area specifically could see another 2 to 3 inches of rain in the next 24 hours. The Ohio Valley in general could see 1 to 2, and some spots in the northern plains could see another 1 to 2 inches of rain. And then last but not least, all the risk areas today, there is a 2% risk for a spin up or a small isolated tornado. Okay, so time frames. In the northern plains, it looks like things are going to start around 20Z or 3 p.m. Central Time. There is a little bit of convection as we speak right now, which I will talk about in a second. From central Illinois to the Ohio Valley, things are already happening right now as we speak, but it's going to start ramping up around 20Z, which is 3 p.m. Central Time or 4 p.m. Eastern Time. And then for the Northeast, looks like things are going to start around 17Z or 1 p.m. Eastern Time, and they're going to last throughout the afternoon and evening. Looking at 500 millibars or midway through the troposphere, the biggest theme today is going to be wind shear. Greater wind speed aloft equals greater wind shear, which is going to tilt those updrafts and prolong those storms. Looking at the northern plains, we can see that we have a really broad trough, and within this trough, we're going to have 2 wind speed maximums. So in these places where the wind speed does increase, we're going to see the most potential for these updrafts and these thunderstorm development. And then from central Illinois to the Ohio Valley and also in the Northeast, we're going to see that we have even better shear. If we look at 300 millibars or way up in the troposphere, we can see that we have pretty well-defined jet streams. And these jet streams are going to be the barrier between the warmer air and the cooler air. And now with that being said, going down to the surface, we can see that we have a cold front going all the way from the Northeast to the Midwest. And this is going to be responsible for most of the surface lifts in these areas to produce these thunderstorms. So as a quick reminder, low pressures are counterclockwise flow and high pressures are clockwise flow. So we have a surface low pressure centered around Pennsylvania that's bringing in warm, moist air from the Atlantic. And we have a high pressure in the south that's bringing in warm, moist air from the Gulf into the Central Plains, into the Midwest. And then we have a low pressure east of the Rockies that's bringing in some of that warm, moist air into the northern plains. Now these winds in the northern plains are significant because the winds are coming from the southeast. They're going into higher terrain, which is going to cause orographic lift. And because the winds can't obviously go through the ground, they got to follow terrain upward, it's going to literally force surface lift. Now earlier in the video, I mentioned the convection that's happening this morning in North and South Dakota. This is going to be really important because these thunderstorms are dropping cool, drier air in this area. And because we're having southeasterly winds bringing in warm, moist air, we can imagine that this is going to bring kind of like an outflow boundary and producing almost like a mini localized cold front and producing more surface lifts. And that's why we have a